It's Tuesday, September 29, 2020. I'm Matt Miller at Trekzone HQ. This is Talkin Science. Coming up today, detailed images emerge from M87, the supermassive black hole first captured last April. NASA announces it's on track for the bold return to the moon timeline, with the uncrewed Artemis mission scheduled for liftoff next year. And 3 lakes of liquid water potentially discovered on Mars, trawling through archival data, pays off for astronomers. Those stories, plus the headlines, right after the opener.
Beaming around the world with the latest science and space news on Facebook Watch, YouTube, and wherever you get your podcasts. This is Talkin Science with Dr. Brad Tucker and Matt Miller.
It's another Tuesday. It's another Talkin Science. Dr. Brad Tucker is with me. Brad, happy Tuesday.
How's it going?
Really good, my friend, really good. The winter months certainly seem to be behind us. We're moving into summer, which means that we've almost completed 2 years of Talkin Science.
Yeah, two orbits around the sun, which, you know, if we were on Pluto, that would be like over 5,500 years. So, you know, it's all relative.
It's certainly, 2020 certainly feels like 550 years.
Right, it really does.
It is incredible to look back as we start taking stock of the year that was, and just looking at what planet Earth has been through in this year. It certainly has been one not without its challenges.
Look, yeah, you know, from what's happening in the U.S., even so with the wildfires and stuff like that, it's a challenging year. Hopefully 2021 is a bit more normalized in the stochastic noise of statistical chaos, ultimately. Let's hope this is a weird fluctuation from the norm.
Exactly right. Well, people can find out more about that fluctuation from the norm as you do your social media thing on Twitter at BTucker22, on Facebook, Dr. Brad Tucker. I'm on Twitter at Merrimat86, and of course Trekzone all over social media. Brad, time to get the show underway.
Talking Science headlines.
And we're kicking it off, Brad, with astronauts taking shelter. The space station is having to dodge some pretty big chunks of orbital debris.
Yeah, this is definitely an interesting one, where it's not something we often hear about, but dodging satellites or dodging space debris for satellite is a real issue. And in this case, there's a piece of hazardous debris near-ish in the too close zone, so to speak, for the International Space Station, where they had to do an avoidance maneuver, and it's actually the third one they've done this year.
Those avoidance maneuvers are getting a little bit more frequent.
It was something like where, you know, it only happened 10 times in a few years, and now it's happening multiple times a year. And in each case, they shoved the astronauts into the emergency capsules, because there's always a Soyuz, or in the future, SpaceX capsule on board, so there's always a way down. And they were put in there just in case it didn't go according to plan. And as more space debris is put up, and as more humans are put up, there's more of this risk will keep happening, and really highlights the space junk issue we have.
Well, for those moments that don't quite work out, it's going to be okay for those astronauts because NASA's sending a new toilet up there.
Yeah, so they've been designing and testing this new toilet to work in microgravity, to consume less power and take up less volume, so more compact and lightweight for when you're on the move and you need to go. And so they'll be sending it up to the space station this week to do the next round of lunar space testing.
An interesting one. It's a new design and one that's taking into consideration the varied crews that are now moving into space, with a special seat to be more accommodating for female members of the crew, and a funnel for men. It's pretty icky business, but the last thing you need is to have that sort of stuff floating around the station.
That's right. So instead of just the vacuum cleaner-like tubes, there's a bit more comfort. And they're also looking at odor control, which everyone thanks them for.
Unfortunately, they're not allowed to take Febreze or Glad or another toilet spray up.
That's right. You cannot light a match on the space station.
That'll be a little bit embarrassing. Well, let's bring it back to high altitude. So we're coming back down a little bit from the space station, and there was an in-flight breakup of a high-altitude pseudo-satellite unmanned aerial vehicle, codenamed Zephyr from Airbus.
Yeah, so this has been an interesting project that they've been building which is a high altitude, so it flies around 20 Ks, essentially big UAV drone. And the cool thing about this is it has the ability to fly for very long time, for long distances, and has a lot of promise for a variety of things where you kind of want higher than where a drone can go, but you don't quite need space, but you want to get high-ish. The stability is all great, but it had a breakup due to unstable weather in one of the flights in Australia earlier.
And that is very cool. They're launching from remote Western Australia with this UAV that has a wingspan of 25 meters, but it weighs less than 75 kilos. This is it's the next generation of UAVs and of these pseudo satellites.
That's right. It's a very long wingspan. It actually helps with the stability at its heights. The lightweight means you can actually carry decent sized payloads and equipment on it. Something where we've even looked at, can we put telescopes and fighter monitoring services on there because of the area you can cover, and they can stay in there for a very long time. So it's definitely something that Airbus has been working really hard on and getting closer and closer to larger operational scale. And in this case, it didn't unfortunately quite work. And look, and this is why you test and design and retest and design before you enter full scale operation.
Absolutely right. And they're, I believe they've got 3 of these models in various stages of development, with 3 more planned. With this one that has failed, it suffered some unscheduled or uncontrolled rolls based on some unstable atmospheric conditions. So they'll certainly need to look at all the data on those and assess what went wrong, because if it's having some trouble at 5,200 feet, getting it up to 26 kilometers might be a bit of a hurdle.
That's right. It's going to have a bit more of a trick to get to their stable cruising altitude. That's right.
Talking Science, Stories of the Week.
And Brad, let's dive into the meat of the show, the stories of the week, if you will. And we've been analysing that black hole and watching the wobble shadow. This is very cool.
Yeah, when that first image of a black hole was released April last year, it's really exciting. And they obviously had a lot of data on it, as in it wasn't just a one and done photo, that they've been imaging it for years. And what they looked at, it was essentially a time lapse of all their data. So, as the resolution got better, they got finer and finer detail of the boundary of the black hole. But what they're also able to do is to monitor what we call the accretion disks. That's the swirling gas and stars stuff that's swirling around the black hole. If you picture that orangey red donut looking thing. And by seeing the wobble, it's actually giving us an insight into how fast these black holes can accrete or suck in material. And so giving us a glimpse of the activity of a black hole in a way we really just never thought we could.
That first image of the black hole was quite blurry, but we thought it was the best thing since sliced bread. And I think it's a condensed version of just how technology has changed over the decades to now get this really super crisp image and be able to study it over multiple days, turning into some years. Better understanding black holes, which is probably a good thing if one decides to swing by.
And one of the big questions is always, how do we understand the accretion rate? How do we understand what these black holes are exactly doing? Because the stuff swirling around it gets near the black hole, gets heated up, melted, burn up, essentially. Really an exciting thing. But one of the things that is quite interesting is by seeing that wobble, it starts to rule out actually some models of accretion of a black hole and what actually it could do.
And the telescope studying this black hole is the Event Horizon Telescope. It's a collection of telescopes, not just one here on Earth.
That's exactly right. The Event Horizon Telescope was trying to use all these radio telescopes all around the world, linked as one. By looking at longer wavelengths, you can have bigger spacing between it because the wavelengths are literally longer. That's why radio telescopes are a lot bigger in size than our optical telescopes. And by spacing them all around the world, you can use the width of the world as a big set of eyes, and therefore a big way of resolving the thing you're looking at. And in this case, as they built more and more telescopes, you can see in this image how the image gets clearer and more detailed. And it's those subtle features of that wobbling. It's kind of like, I think, water going down a drain, right? The water sloshes around. And these details are very important because you never thought we'd see them, I think, to be honest. It was never imagined that we'd be able to see in real time the flow and rate of an accretion disk and flow of gas in around a black hole on the scale of years as opposed to absurdly billions of years.
Exactly right. And just to think of the scale of this telescope, which is leading to enhanced resolution, as you say, it's dishes around the world, including one at the South Pole. So you basically have this receiving station the size of the Earth, which just really helps to narrow in and gain that detail and just give us these stunning observations. And this M87 black hole was discovered when we first started talking science. So it's nice to come back to it and see what's happening with it a little over a year later.
Exactly. And, this is just the beginning. There'll be more images taken. They're building 2 new facilities. And they're obviously looking at other black holes, including Sagittarius A star, the one in the center of our galaxy. So lots of, excitement still to come.
Alrighty, Brad. Next up this week, NASA has published the Artemis plan to land the first woman and the next man on the moon by 2024. And it looks like we're going to be kicking off things next year.
Yeah, this is something that we've talked about a bit. We talked about the static fire test of the Space Launch System a couple of weeks ago, how the Orion capsule was testing. And so kind of this is NASA saying, where are we at? Where are our plans? Can we make that 2024 launch? And surprisingly, it looks like it's all on track. That Artemis 1 would take place next year. Artemis 1 being a uncrewed trip around the moon. Artemis 2 having a crew but not landing on the moon, going around it like Apollo 8. And then Artemis 3 in 2024 actually landing people back on the moon. And when they thought of doing that, it was a very ambitious plan. And NASA saying, hey, we're on track. And that was the biggest surprising thing is they're on track, especially given what 2020 is throwing.
Yeah, absolutely. Maybe they've just gone back through the archives and had a look how they did Apollo and just we'll just do that again.
Look, they obviously would have been referencing things, but I think it's finally that there was a big push, concerted effort. And as they noted, bipartisan support. Both Democrats and Republicans are supporting these initiatives. So the funding's there. These wins are now starting to pile up where you're starting to see the light at the end of the rocket.
I think NASA should be a little bit careful though, because they are setting a bit of a precedent now. This is going to be the second time that a president has put them on a tight deadline and they're going to meet it. So now we know how to motivate the American Space Agency and get them to a big goal.
Yeah, that's exactly right. Is similar to Kennedy. They had this ambitious timeline for Artemis, and they seem to be on track. Because even if they slightly slip to 2025, just for random scheduling reasons, no one's going to be disappointed and obviously and surprised that they made it this quick.
We're heading towards phase 1, which, as you say, is Artemis 1, uncrewed to the moon, very similar to how they really sort of got started with Apollo. It is exciting times ahead to even just have an uncrewed mission heading off an outside low Earth orbit for the first time in 40 years, 50 years even.
That's right. It's really exciting what the future holds, to be honest. And as you said, just like the Apollo breaking up into the smaller missions, just in this case, they kind of know the big testing points. So instead of having to do the 10 really Apollo tests, they can combine a few into different ones to know what the different goals are and the different milestones instead of breaking it up into smaller chunks. So learning from the Apollo missions, both in terms of what they can condense or what they can combine and what they need to individually test.
And once we get to the moon, just reading this press release from NASA, very cool that the modern spacesuits are better than Apollo, which means that these guys are going to be staying on the surface for longer, almost 7 days, a full week on the surface, doing a lot more. And it's really strange to think that there's only been 12 men on the moon, and there's only been maybe a combined 2 weeks on the moon's surface in all of our human history. We're going to go back and we're just going to smash those records and learn so much more. Scientists like you, Brad, are going to have a really busy time in the later part of this decade.
Yeah, look, lots of a different view. It will be a very different world, and they also talked about the Gateway, the space station around the moon, is still on track, and it's reaching its goals as well. There's been calls for scientific payloads, and in fact, I helped write a paper about launching a telescope on the Artemis mission so they can put it on the surface of the moon. And so, yeah, lots of things happening in pretty quick succession, and that's the exciting bit here.
Now, one last thing that I wanted to touch on here. My mum and I were talking about this on the weekend. She believes that we shouldn't be going back to the moon. We shouldn't be going back to mine it, to extract its resources for fear of damaging the moon in a way that affects us here on Earth. What do you sort of say to that, Brad? Should we be going back? Should we be mining the moon? I know that's sort of a little different to Artemis, but that's sort of going to be coming along with all of this as Artemis takes us to Mars as well.
Yeah, I mean, extracting of resources on the moon is critical to success. Look, I think the terms of the effect on Earth is going to be minimal. We've done a lot more mining on Earth, and we haven't noticed actually dramatic changes in our gravity and stability. Those aren't really going to happen on the moon. There's ethical questions to ask. There's the security and policy implications of what happens when you start down this path, all which are fair to ask. And there has to be a right balance to doing this, in fact, because I think the positive spin-offs of extracting of space resources is way more than the negative effects. But it needs to be properly thought out, and those conversations need to be had by all parties. But it shouldn't just be about self-interest of what the moon does to Earth. It should be about how we treat other things in space.
And as we talked about last week, that space treaty is being urged, including Christopher Pine, our former defense former secretary, that's a bit American, our former defense minister, calling on the UN to help broker that space treaty to avoid those self-interests excavations, if you will, of the moon. But certainly the progression and the scientific knowledge that can be gained by getting us further into the solar system is well worth any risks or even the effort.
Well, look, I think we have to make sure all the risks are properly weighed up. But yeah, lots of different groups calling on us just to make sure that we think this is well thought out as possible before just rushing into it.
You can get social with Trekzone. Australia's unofficial home of Star Trek is everywhere you are. Just search for Trekzone.
And Brad, last up this week, water on Mars. No, it's not a repeat headline from a little while ago. There's a new discovery, 3 buried lakes, and they're intriguing researchers.
Yeah, and just announced just the other day, there was a hint from Mars Express data about a year and a half ago now of a subterranean lake on Mars near the cap. And a further follow-up study of more data and more analysis has shown that not only has that lake been confirmed, but they found 3 more in the process. In fact, that there appears to be way more lakes underneath the ground of Mars than we previously knew about, which is an exciting possibility for lots of different reasons, for supporting both future humans, but also for supporting potential life on Mars.
Now, I can't believe it was 2 years ago that the first discovery of water on Mars was made.
Yeah, exactly. So, there's always been hints of ice, and it's always been the question of, is there liquid water underneath the ground? It's been predicted for years. In fact, a colleague friend of mine here in Canberra, Charlie Lineweaver, and a student predicted this a number of years ago. If you look at the pressure and temperature of Mars, you'd expect the liquid to survive more underneath the surface. And the exciting thing is that's exactly what they found. And as this new study found, they found more of them. So this is a common, or at least potentially common, feature of Mars, which for all those aforementioned reasons is exciting, but it's also just exciting in terms of the evolution of Mars as a planet, how it's gone from surface water to subterranean water. Did it always have subterranean water and the surface water? Did those change? How salty is it? What are the possibilities for supporting it? And all those questions that we want to know about how our planet evolves and how Mars evolves as well.
Well, this discovery, reported in the last couple of days in Nature Astronomy, was made using radar data from the European Space Agency's Mars Express spacecraft, which is in orbit of the red planet at the moment. And it's, as you say, they found one and then they found three. So this is very cool, and it's based off 29 observations from that spacecraft between 2012 and 2015.
Yeah, and this is the cool thing about Mars Express, is because they have such a long database and a long timeline, they can look at a lot of this data repeatedly, get different measurements, and get really precise ground telemetry radar. And I think this is kind of the cool technique. It's not too different than what we do here on Earth. People use ground penetrating radar all the time. And, the simple thing is, it's kind of like, all right, well, let's just do that on Mars. Yeah, all right, that makes sense. Let's go do it. And this is what you find.
I should, of course, mention as well that I mentioned 29 observations there. They also then went back and studied 134 more from 2012 to 2019. So, as you say, having this massive library of data on Mars, it's been a planet that we've been studying for so long, and it's just there, just out of reach at the moment. And learning more and more about this stuff really makes it worthwhile to go and have a look and see what's going on, if for nothing else than our own human curiosity.
Yeah, and I think this is kind of the interesting thing, right? There's a lot of reasons to explore Mars and study Mars. And this highlights a great thing is there's lots of ramifications for this discovery, but the principle is just trying to understand more. And this is a critical role sometimes that astronomy and space exploration play, that humans are inquisitive and creative by nature. And if we don't follow that, if we don't ask those questions, we kind of lose an essence of humanity. And this is a great example of that, and what it leads to, and then what this may lead to in the future by doing these sorts of studies.
Now, there is still some debate amongst the scientific community as to whether these are actually liquid water lakes. Some researchers are saying that there's not enough heat to turn the ice into water. There's really only one way to find out.
There is only one way to find out. And look, it is debated. As you said, it was debated when the first announcement came out, as you said, about 2 years ago. And, so this study essentially said, try to confirm this through different techniques and more data, and found the same thing in more of them. But some also say that it can be possible. So we won't know until people do some excavation on the surface or some sort of experiment. But we will have an answer. And then the question is, what is down there when and if we get down there to look?
Absolutely. Well, the Chinese mission Tianwen-1 might answer some questions, or might even propose some new questions. It's going to enter orbit in February next year. It's going to have a orbiter as well as a rover heading to the surface, and that orbiter is going to have some scientific instruments on board, including some more radar. So if there's one thing Mars needs, it's more radar equipment.
Exactly, that's right.
Fantastic, Brad. Well, I say it every week, but it is true every week. It's fun to pick apart the stories of the week with you. Looking forward to doing it again next week.
Sounds good.